people in.
Hi, everyone.
Yay.
Welcome to today's webinar. Glad to have you all. We'll just let everyone come in to the Zoom room for a minute. But thank you all for joining us for Confessions of a Recovering Engineer, Transportation for a Strong Town.
We should, yeah, okay. This is a nice, healthy crowd here today.
Yeah.
Very cool.
Yeah, so thank you all for joining us. I'm Rachel. I'm the program director at Strong Towns. In a minute, we're gonna hear a special presentation from Chuck Marohn, the president of Strong Towns. That's based on his book, Confessions of a Recovering Engineer. And this is a special offering. It's our member week, and we always like to do some special things to just let you all kind of in on what's going on at Strong Towns. And this is all made possible by our members. So we really thank everyone who is a member supporter of Strong Towns. You all make this movement everything that it is. Everything from our webcasts, our articles, resources, podcasts, it's all possible because of our members. So thank you.
Very much
and
so.
And if you haven't yet become a member, please do.
Yeah, I was thinking, I'm headed out to California tomorrow, and I've got 2 weeks now in California over the next 2 weeks, and so much of that is happening because of members, because of people who are involved in Strong Towns, people who have stepped up and said this message is really important. We want to share it in our places. And yeah, I actually just was chatting with someone here, and they said, "Where's the last place you went?" I was like, I went to Winnipeg, and Winnipeg was this awesome experience with just a room full of people super excited about this message. I gave the presentation there that I'm going to give today from the book tour. And it felt like we were making a huge difference. Like people were taking this stuff and not only hearing it and being excited about it, but actually then turning around and doing something extraordinary. That's what our members are. And so, yeah, we wanted to do this week to say thank you, to encourage those of you that aren't members to sign up to become members, and just to be very grateful. This is a growing movement, and we're seeing more and more good things happen as a result of our members and the work they do.
Yeah, love seeing all the hellos from everybody. I think we've got at least like 30 states and several Canadian provinces. So thanks so much, everyone, for joining us.
You started this a while back for us. I'm sure other places do this. I've not seen it done the way that we do it here.
Grayson Johnson.
Okay, you did it once, and now you don't even ask people, and it just takes off. And I love it because I'm sitting here on my screen getting ready to do this presentation, and I'm seeing Vermont, West Virginia, Maryland, Kentucky. Like, this is amazing. Thank you, everybody. Plano, Texas. Yes.
Yeah. So we'll hand it off to Chuck to do this presentation, and then we'll also have a little bit of time for Q&A at the end. So if you'd like to submit questions as the presentation's happening, feel free to put those in the Q&A box at the bottom.
And you will moderate those when we get to the end, right?
Yep.
All right, sweet. Thank you. Thanks, Rachel. And just by the way, those of you who have been around here for a while know what an extraordinary job Rachel does outwardly, but inside the organization, she's the one who keeps everything running. And we could not do any of this without her. So thank you to our members, and thank you to Rachel for all that you do. Confessions of a Recovering Engineer is the latest book that we worked with Wiley Publishing to get published. We're going to go through some of the overall concepts today. We picked Tuesday to do this. Tuesday is the day we announced our campaign to end highway expansions. If you haven't seen that campaign yet, go to strongtowns.org. We got a little write-up on it. Yesterday was our Safe and Productive Streets campaign. Tomorrow we'll do transparent local accounting, then incremental housing, then parking mandates and subsidies at the end of the week. A little write-up launching those campaigns. Today, end highway expansions is such an important one because the money we spend on transportation, the money we spend expanding highways, not only is kind of an abrogation of our duties to maintain the things we've already built. There's a moral dimension to that failure. But also, this is the greatest challenge we have. It's kind of the greatest enemy to building strong towns that we have, is this continued obsession with top-down highway spending. And so go read about that campaign, and we'll get into that a little bit here in the presentation. All of you on this call remember this, right? It was a little over 2 years ago when there was this massive drop in traffic because of the pandemic. It was eerie. In fact, I remember just, going out for a walk and not having any cars anywhere, and just thinking, okay, I'm happy for a world without cars, but this is really, really eerie. I want to show you how big of a drop this was. I'm a chart person. I apologize for those of you that are not, but if you just take the broad outlines of this is vehicle miles traveled over time, and it kind of shows how vehicle miles drop during recessions. We'll look at the far right. The amount of drop we had in miles traveled was unprecedented. It was an enormous collapse in VMT, something that we've not seen in the automobile era, certainly not over the last 40 years. If we ask people to talk about, the theory of traffic safety, the way that engineers, the way that transportation professionals approach safety is that safety is directly correlated with miles traveled. If fewer people are driving, fewer drivers will make errors. We know, and I'm saying we know in air quotes because I disagree with this statement, but we know that crashes are caused by driver error predominantly. There's a US DOT study that says 94% of crashes are caused by driver error. And so if fewer people are driving, there'll be fewer opportunities for drivers to screw up and make mistakes, and therefore deaths will go down. That was the theory. And if you had talked to any transportation professional prior to 2020, that's what they would have predicted, but that's not what happened, right? Traffic went down, but deaths went up. Traffic went down, but crashes went up. Traffic went down, but fatalities and traumatic injuries went up. This went against every theory of traffic safety that we have, or every operative theory, every theory that is in play from the National Highway Transportation Safety Board on down. This was baffling to everyone, and they set out to try to figure out what was going on. What is causing this? What is the underlying problem? And of course, if you've been following Strong Towns for this year, we've written a lot about this and talked a lot about this, because the way we explained, or the way that the authorities in this field explained this to us, was the reckless driver, right? The pandemic made us, transformed us into deviant people. We are now more reckless than we've ever been. And that recklessness is the direct attribute, or the direct cause of these crashes. Yes, traffic went down, but reckless driving went up. This is a very seductive narrative, because of course, everyone on this call knows someone who is a reckless driver. Everybody on this call has been in an instance where they've been near someone who they looked at and said, this person is reckless. I'm going to posit something here that we may not want to hear. I'm going to give this to you, and then we're going to come back to it a little bit later. Everybody on this call has been, at one point or another in their life, a reckless driver. If you've gone, a couple miles over the speed limit, if you've not come to a complete stop, if you switch lanes without proper signaling, if you've listened to the radio while you're driving and not paid 100% attention to the road, you are, one of these people who is a reckless driver. This is a category that, from a driving standpoint, there's certainly degrees of recklessness, obviously, but in terms of crashes, the reckless driver is a subset of everybody. Yet that didn't keep us from going with this narrative, right? This narrative was very affirming. It kind of captured everything that we wanted to believe about each other during the pandemic. We saw in the early days of the pandemic that people were coming together. There was common purpose. There was common cause. As time went on, we saw that divisiveness that has crept into our society start to creep in. And these narratives really fit comfortably in that more divisive framework, right? This is the other that is causing this. Pedestrian deaths spike because we've got all these reckless drivers. Drivers have larger vehicles. They're fraying social norms. They're doing all these deviant things. It's not just your imagination. Dig deep into that fear category of the other. We're going to affirm to you that drivers are more reckless now. They've done more reckless things again and again and again in major publication after major publication. We had this theme of reckless drivers. And then, of course, this was my favorite quote. This was from an LA Times article. Interviewing a safety official, and they said reckless driving is, quote, a sign of the overall lack of consideration we're showing for other citizens, whether it be wearing masks or not getting vaccinated or how we drive. It's very aggressive. It's very selfish. If you want to, have a category of people that you don't like, and then you can take a social ill and channel that dislike or discomfort or anger towards them, we as traffic safety people are going to make it very easy for you to do. I think that this is reckless in itself. I think that this is not only bad public policy, it is, antisocial, very destructive. And it turns, I think, in a very convenient way, the introspection that we should be having on why these theories of traffic safety are not working away from the real cause of the problem. And it distracts us to, again, fighting amongst ourselves. Here is a graph that engineers are generally very proud of, right? In blue, and again, I apologize to the people who don't like graphs, just big picture, you don't have to get into all the details here. In blue, from left to right, we have going up, vehicle miles traveled. And so what this blue line says is that people are driving way, way more than they ever have. Since the 1920s, traffic has gone up. We're driving way and way more. The red line shows deaths per mile traveled, right? So what it shows here is that even though people are driving more, the number of people that have died per mile travel is way, way down. Travel itself is becoming safer and safer and safer. And engineers point to this and say, this is because of us, right? We have designed systems that are safer. We have made changes that would make things safer. We now require airbags and seatbelts. We're creating vehicles that are more crash resistant. We have done all these things and we have solved this problem. But I want you to look at the direction of these lines, right? Vehicle miles traveled go up, deaths go down. And this is a very affirming narrative. I think that engineers have a case to be made, particularly for the first 50 years shown in this chart. The early automobile days were ridiculously dangerous. We took old cart paths and put high performance surfaces on them and high performance vehicles on them. And the rate of death, the rate of fatalities was astronomical. It was just horrific. Over time, we figured out how to build highways. We figured out how to build big infrastructure to move people at distance in a very safe way. And you see that reflected in the post-war era with vehicle miles traveling going up really steady, but deaths seeming to come down. But if you look at the right side of that chart, in the red, what you see is a leveling off, a general leveling off over the last 30 years, where traffic deaths have remained persistently high. They've remained stubbornly high. And regardless of all the things that we've done from an engineering standpoint, we've not been able to get this number to go down very much. I want to talk about a different causal effect here. This is a chart not of vehicle miles traveled, even though the direction and the scope of it and everything looks like the vehicle miles traveled chart. This is actually a chart of time spent wasted in traffic. This is a chart essentially of congestion, time lost to congestion. You'll notice one thing about this chart, it looks exactly like the vehicle miles traveled chart, right? They're very, very, very similar, very same trajectory. What's going on here? As the number of miles traveled have gone up, so has traffic delays, so has congestion, so has the amount of time spent stuck in traffic. And the fascinating thing, or maybe not so fascinating, but the obvious thing about being stuck in traffic is that it's very hard to kill somebody when you're not going anywhere. It's very hard to have a traumatic brain injury when you're stopped. And so Americans are spending more and more time stuck in traffic. They're spending more and more time traveling, sure, but more and more time not going anywhere and not going anywhere fast, particularly as we head up to the pandemic. This is the thing that changed the most dramatically, right? If we're looking for a theory, if we're looking for an explanatory effect, what we did with the chart on the right is we eliminated that, right? When we dropped the amount of traffic, engineers thought that the amount of deaths should go down, but they actually went up, and they went up for a very simple reason. There was no person in front of you slowing you down. And so the full expanse of the systems that we built were revealed, and people were able to drive very, very fast, AKA reckless, but they were able to drive the speed that the streets were designed to drive, the speed that the strodes were designed to be driven, the streets that our highways were designed to be driven. And what we saw is that at those speeds with that complexity, fatalities actually went up. I want to get into the actual design parameters of this, because once you grasp the rationale or the reasoning behind the way we design our transportation systems, this correlation between congestion and the reduction in congestion and overall increase in traffic deaths becomes very clear. The reason for this persistent, stubborn number of deaths that we have that we can't seem to get rid of, despite all the efforts we have at over-engineering and over-designing and building bigger and more complex systems, why those traffic fatalities stay around that 40,000 a year mark and won't go away. It becomes very obvious. So let me walk you through this, and let me go back to the very kind of essence of the way we build and design our transportation systems today in the US, that being the hierarchical road network. We're all familiar with this. We might not even identify it as a hierarchical road network. It's just the road network we've been given, right? Local streets pour into collector streets pour into arterials into major arterials, and on and on and on. Little goes into big, right? It's a very simple concept. If you're on any kind of a part of our automobile-based transportation system, you can tell where you are based on the size of the street and where you need to get to. As an analogy, I want you to think of a watershed. We all recognize in a watershed that water will flow through ditches and creeks into little streams and brooks. They will flow into rivers. Those rivers come together to make major tributaries. We grasp that in a watershed, when it rains out on the periphery, if that rain is intense enough or persistent enough, all that water will come together and we will get a flood. This is hydrology 101. And as a civil engineer, I had hydrology 101 as a class. We spent about 5 minutes on this because it's a very simple, straightforward concept. But for some reason, when hydrology 101 ended and we walked across the hall to traffic 101, we have the same exact kind of system dynamic. We become very, very confused when there's a little bit of action out on the edge, and that action comes together and creates a flood. It's the same kind of mechanism, right? It's the same kind of system. In fact, if we set out to design and build a transportation system that was designed to generate the maximum amount of congestion possible every day, this is what it would look like. This is what we would build. We would take everybody who it was possible to get in a vehicle. We would get them into a vehicle at the same time every day and channel them, funnel them into the same place. This is why congestion is a ubiquitous condition of the North American development pattern. This is why we experience congestion in every city, big and small, all across the US. If you came to my little hometown here, Brainerd, Minnesota, population 14,000, and asked people at 750, who are out at the traffic light in the middle of town, what do you think of congestion here in the Brainerd Lakes area? They would say, oh my gosh, congestion is horrible. It's overwhelming. We got to do something to add more capacity. And 10 minutes later, there would be no cars on the road. Congestion becomes a ubiquitous condition with this style. But because of this, we respond with a very clear, clear set of things. We overbuild. right? We over-engineer, we over-design. This is the response of a system that has a lot of money to tackle the problem without having to think very hard, right? We have congestion, there's congestion here. Instead of looking at system dynamics and what have you, we just widen out the road. We're getting a flood. What do? We just widen out the river. We widen out the basin. We build more dikes. It doesn't work in flooding. It doesn't work in traffic either. But that doesn't keep us from doing it because we, again, have the budgets to do it or have had the budgets to do it. And so this has been our standard approach to congestion. You combine this with the idea of forgiving design and you get the basic essence of our transportation system. Forgiving design, which engineers today would just call design, is the kind of underlying theoretical framework for how we increase safety in our transportation system. We increase safety in our transportation system by giving drivers more room, by giving drivers more buffers, by, in a sense, forgiving the mistakes that drivers routinely make. So the idea is we have a 2-lane road, for example. We know that drivers will, really for no malice, no ill intention, just as a normal course of driving a vehicle, sometimes sway a little bit in their lane. Right? Maybe they look down to change the radio station. Maybe they're distracted by a kid in the back seat, whatever it is. We know that they will drift a little bit. When they drift, we don't want them to drift across the center line and hit someone coming in the other direction. And so what we do is we widen out the lanes. We give them a little bit more room to move. We know and understand that drivers will at sometimes, really through no malice, through no huge fault of their own, actually leave the roadway. They'll depart from the road surface. We want to make sure that they can recover and get back onto the road without some type of catastrophe happening. And so we give a little bit of recovery area on the edge. We give a little bit of room for them to retain control of their vehicle and go on their way. We understand that despite our best intentions, despite everybody, proceeding earnestly, sometimes a vehicle will go completely off the roadway. And when they go off the roadway, they will have a lot of kinetic energy that needs to be dissipated before they run into something that doesn't move. And so what we do is we clear out the obstacles from the edge of the roadway. And now we have what we would call a forgiving design. If you remember back to that chart I showed you with the blue line going up, the vehicle miles traveled, and then the deaths per mile traveled going down, a lot of the deaths per mile travel going down is attributable to this approach. This approach is brilliant. It has saved millions and millions of lives. I like to point out today that if we had the same rate of death per mile traveled that we had in the 1930s, today, instead of 40,000 people a year dying on our roadways, we would have over 500,000 people dying on our roadways. Forgiving design has saved millions and millions of lives. This is a genius approach. It's been copied all over the world. Yet there's something wrong with it. There's a deep flaw in it. And that deep flaw manifests when we take this idea, this concept, this theory of how we create safety by adding room and buffers and recovery area, and we bring it into a city. We bring it into an urban place. We bring it into a place with lots of complexity, lots of things going on. Because, of course, we recognize that what we're doing for a driver with this design is we're signaling to them, we've got your back. We have designed in a way that forgives your mistakes. We have created extra room for you to move. We've reduced the number of conflicts that you have. And so drivers naturally respond to this type of engineering by speeding up, by going faster than what conditions would provide. They do this in an environment with a lot of complexity. Because unlike a highway where forgiving design works really, really well, when you bring forgiving design principles into an urban area, you are combining a false sense of security on behalf of a driver with lots of complexity. The complexity of vehicles that would randomly stop, randomly turn into traffic, turn out of traffic, stop and park, pull out of parking spots, crossing traffic. You add the complexity of humans in this space, humans on bikes, humans walking, humans in wheelchairs, little kids chasing their dog out into the street. All of these things become random occurrences in a complex environment where we are inducing people to drive faster than what a full awareness of that safety would suggest. This misunderstanding or misapplication is deep and fundamental to the North American engineering professions. This is the Manual on Uniform Traffic Control Devices. This is oftentimes referred to as the Bible by traffic engineers. It's one of the key manuals we use to design where signs should go, where signals should go, how intersections should be laid out, et cetera. If you go to the Manual on Uniform Traffic Control Devices and you say, explain to me the difference between an interstate highway and the local street out in front of my house, you will look up the definition of a street and it will say street, see highway. Literally, there is no discernment between the two. The book treats these environments as if they are the same, despite them being vastly different, having a vastly different approach that is needed. This puts us in this crazy situation that we all experience where you will have a design speed of, say, 60 miles an hour, a travel speed of 40 miles an hour, and an enforced speed of 25 miles an hour. For engineers, this is providing a safety buffer, right? We want people to drive 25, but if we design it so they can drive 60, they've got all kinds of safety buffer. But that's not how a safety buffer works in an environment like this. That kind of safety buffer encourages high speeds, which in reality is very unsafe. I want to, I've become more comfortable showing this. I took it out of my earlier presentations and then I brought it back. I don't want to traumatize anybody with this, but I want to point this out because it is part of the internal cognitive dissonance of a profession that was asked to design highways and then took that knowledge and brought it into urban spaces. And that cognitive dissonance is important for us all to understand and identify. This is a traffic signal, right? And if you look at that traffic signal, you will see on it, attached to it, is a beg button, the button that you would go up and press to request permission to cross the street on foot. You'll also notice at the bottom of that pole, there's a little gap between the bottom of the pole and the pedestal that it's on. Here's a side angle of what this is. If you look in that gap, you'll see that there are pins, there are little bolts, it kind of looks like, that are between the actual pole that holds up the traffic signal and the base pedestal that it sits on. Those are called shear pins. And what a shear pin does is if a force strikes this pole, the shear pin will shear off and the pole will be able to absorb that energy. So if a vehicle comes careening off the side of the street, hits this traffic signal, what we don't want as engineers, what we don't want as designers of highways is to have that person come to an abrupt stop. That will be very traumatic for the person driving the vehicle, the people within the vehicle. And so what we do in the clear zone, in the recovery area, is we design things to shear off. So if a vehicle hits this, it will shear off and a lot of that kinetic energy will be absorbed. So the driver will come to a more gentle stop than an abrupt stop if that wasn't there. Now pause for a second and recognize what we have done. We designed something with the driver in mind, right? We want to make sure the driver is very safe. The driver will be potentially going here at lethal speeds, at speeds that would be lethal if they ran into something and experienced an abrupt stop. And we don't want that to happen. So we design our system so that doesn't happen. Right next to the place where we design people to stand and wait. This is a dissonance that is hard to comprehend. It's hard to explain. It's hard to understand. I recognize that a lot of people get very frustrated, very angry at engineers who are not compassionate and don't care and don't seem aware of the damage that they're doing. This is exhibit A for that. I will tell you, I think it's less malice and more myopia, right? We have asked our engineers to do one thing, to design places to move vehicles quickly, and to do that with increased safety for drivers. And the dissonant approach is that we ignore the complexity. We ignore the experience of people outside of a vehicle. We do things like place humans standing in areas that we know to be so dangerous that we have to build breakaway poles. This runs counter, this entire approach to safety runs counter to what engineers actually know and understand about driver behavior. I find engineers actually to be very sophisticated in terms of grasping driver behavior. There's a fantastic book called Thinking Fast and Slow by Daniel Kahneman. And in this book, he goes through two systems of the brain and how they operate, system 1 and system 2. System 1 is your very fast, very unconscious type of processing. If I ask you, what is 1 + 1? Everybody on this call can say 2. They don't have to, in order to answer that question, move anything else outside of the brain. They can just do that and keep moving on. System 2, on the other hand, is the very deep thinking, slow, kind of methodical process. If I ask you to add 2 4-digit numbers together, somebody could probably do that on this call, but most people cannot. Most people, if they were going to do that problem in their head, would have to stop, push everything else out of their brain and focus on that problem. Well, like carry the 1, do all this stuff in order to come up with an answer. That's system 2. System 1, fast. System 2, slow, methodical. Here's what engineers know and understand about driving, and what traffic safety advocates also need to know and understand about driving. Driving is a system 1 activity. We would like it to be system 2. We would like it where everybody who was driving was 100% focused on the road at all times. That is often the standard that safety advocates, the people who are like, stop killing pedestrians, stop hitting motorcyclists, stop doing, they will say, you're driving a 2-ton lethal weapon, you should be 100% focused. Nobody can do that. That's not a reasonable expectation of humans. If you've ever listened to the radio while you're driving, if you've ever spoken to someone in the passenger seat, if you've ever daydreamed a little bit while you're driving, that is very normal behavior. And it's normal behavior because driving is a system 1 activity. It's something we can do passively. If driving were a system 2 activity, something we had to be focused on all the time, took 100% of our brain power, humans could not do it. Most humans, people who are race car drivers or jet fighter pilots might be able to do this, but most of us would not be able to. Driving has to be a system 1 activity. This recognition of the limitations of the human brain leads to a conclusion that is inescapable, an uncomfortable truth, so to speak. And that is this: people will tend to drive the speed they feel comfortable driving, regardless of any other factor. Regardless of any public shaming campaigns we do, or signs or awareness things, all our little stickers to, drive safe, drive smart, start seeing motorcycles, start seeing pedestrians, be more aware. None of this stuff matters because people drive in system 1. And because of that, they will drive the speed that the street communicates to them is safe to drive, regardless of any other factor. So these kind of things are patently offensive to me. They should be offensive to you as well. The idea that, not only will they exploit little kids in this way, but we'll try to shame drivers into, hey, some mistakes you can't take back. You can't fix a pedestrian. That's the engineer's term for a human being. You can't fix a little girl at a body shop. Slow down, you reckless driver heathen. These are patently offensive because they go against what engineers and transportation safety officials understand about driver behavior, what they understand about how humans actually act behind a vehicle. You can see this in the way that engineers do traffic studies. I worked for the DOT as an intern back in the 90s when I was an undergrad, and I was the guy who went out and did speed studies. We would get a call from a local government. They'd say, people are driving really, really fast through here. And I'd go out the radar gun and conduct a speed study. And we get there, we'd take all the readings and we'd say, is there excessive speeding? If the answer was yes, we go out and raise the speed limit. And let me say, that is the right answer on a highway. That is the right answer. And the reason that's the right answer is because the most dangerous thing on a highway is not speed. It's differential in speed. If you have a highway designed for 65-mile-an-hour traffic, most people are driving 65, but you have a speed limit at 45, and occasionally someone will go into system 2 and really focus for that and drive 45. That differential in speed is what creates your fatalities. That differential in speed is what causes the crashes. Engineers know this, they grasp this. And so the proper response is to raise the posted speed limit, because we know that if we set the speed limit wrong, it's going to create this differential in speed, because most people are going to drive not what the speed limit says, but the speed they feel comfortable driving. For some reason, this knowledge goes away or is selectively used when we get into urban areas, because when we get into urban areas, the response has to be different. We go out and conduct a speed study. Yes, people are driving at unsafe speeds. We need to change the design. We need to actually signal something different to drivers than what we are now signaling. We actually have to show them through our design what a safe speed will be. At Strong Towns, we have a saying: if you need a sign to tell people to slow down, you designed your street wrong. A really good street will explain to the driver subconsciously what is a safe speed. How will we do this? I think I get this question every now and then, like, okay, Chuck, I get it. Like, what does this mean? It looks like the opposite of forgiving design, right? Instead of widening out lanes, we narrow them up. Instead of adding recovery area, we take that away. We actually put ballers and other things on the side of the street. Instead of removing the trees and creating a clear zone, we actually bring the trees back and create some edge friction. These things signal to drivers that they have a much lower margin for error. The actual margin of error they have is very low. We want to correctly signal that to drivers. And so this correctly signals to drivers, and drivers respond by slowing down, by driving slower. And slower speeds in urban areas is the number one way to improve safety. If you go to engineering manuals, they'll often have something like this, a little chart showing the kind of happy trade-off between arterials and local streets. In arterials, it's all about mobility. It's all about moving vehicles quickly. On a local street, it's all about land access, which is a geeky way of saying building a place, right? On a local street, we're in a place people want to be. On arterial, we're moving between places. In the middle there's this place where you have your metaphorical cake and eat it too, right? The collector street, where you can both be in a place and be moving quickly through a place. If you've heard us talk about this in the past, you recognize that when it comes to making good investments in infrastructure, these two ends are really great investments. We can build great roads that connect places, do that very cost effectively. We can build great places and make investments in public streets that pay off many times over. It's this middle area here where we're not in a place, we're not getting through a place, where we spend an inordinate amount of money moving vehicles quickly, but don't get much financial return for it. At the same time, we recognize that these end spectrums are very, very safe. Highways, when you see that chart going down of deaths per vehicle mile traveled, almost all of that death savings, almost all of that reduction in fatalities comes with safer highways. That's what it is. We can build highways really, really safe, move people at great distance at speed in very safe environments. Local streets are also very, very safe. Insurance companies will tell you we have a lot of claims on local streets. They do. They tend to be of the fender bender variety, the dented door variety, not the traumatic brain injury or fatality variety. Those happen in this middle area where we're traveling at lethal speeds, but we have the complexity of trying to also build a place. If you take this chart and you flip it on its side and you ask a different question, at what speed do we create the most value? What we see is that we create the most value when we're at very low speeds, when we're building a street, and we're at very high speeds when we're building a road. A street being a platform for building a place, building wealth in a community, a road being a connection between two places. Where we have the least amount of value in our transportation investments is this area in the middle, the area that we call a strode. A strode being the default option that we use to design urban spaces today. This is our quintessential strode. We think of a strode as the futon of transportation, this amalgamation of street and road, trying to be both good for through traffic and good for building wealth. What we see is that we spend an exorbitant amount of money in places like this, trying to move vehicles quickly. The vehicles are not allowed to move quickly, of course, in these spaces. We also spend an inordinate amount of money trying to build wealth and create investment, yet these places tend to be the lowest return per mile, per dollar of foot of public investment. These places fail in so many dimensions, return on investment and safety being just two of them. Strodes are the default transportation investment we do today in urban areas. And if we want to do one thing to fix our transportation budgets, if we want to do one thing to make our cities better places, we will have an active policy of converting our strodes into streets and our strodes into roads. Pick a side, in a sense. I'm going to show you just real briefly how we go about doing this. It's actually, from an engineering standpoint, ridiculously easy. What I always tell people is difficult about this is the cultural overlay we have, our expectations, our understandings. If we want to go from strode to street, very simple, we slow traffic. Like, that's the number one thing. We got to create that edge friction, narrow the lanes, do everything we can to signal to drivers that you need to drive slower. We need to experience slower traffic. We need to prioritize humans in the place over the throughput of traffic. If you go back yesterday to our Safe and Productive Streets campaign, it's all about that. How do we look at streets not as place for moving throughput of vehicles, but places for building a place, building wealth in a place? In order to build wealth, you actually have to build. So a street is all about intensifying the land use, actually building up stuff, and then embrace complexity. I always like to point out that engineers are fond of using manuals like cookbooks to tell them how wide a street should be and how many lanes it should have and all that. When we're building great streets, you cannot take that knowledge out of a cookbook. It does not come from a design manual. There's a lot of complexity that goes into it. In fact, I see a street design manual up here. Victor Dover and John Massagill wrote this book. It's a fantastic book. I'll summarize the book in one tweet. Streets are really complex. Embrace that complexity. If we want to go from strode to road, it's the opposite then, right? We want to speed up traffic. So we're going to limit access, limit the complexity, simplify things down, get vehicles moving quickly. We have to separate our automobiles from our other ways of getting around. You can't put a bike lane on the edge of a roadway where people are going 60 miles an hour, 5 feet away from someone on a bike. I know a lot of cyclists, get upset with that, but the reality is we can't build that safe. We should have roads for bikes. There should be separate facilities that are safe for them. We can't allow the land use to be degraded, that interchange, so that we can have the frontage roads, so that we can have the drive-through and the big box store and the strip mall. Those things all are low budget, low returning types of investments that wreck our collective investment in this roadway capacity. We need to stop doing those things and simplify down. So let's go back to this insight, because I think recognizing these systems for what they are gives us a really good way to think about what should come next in our transportation system. If you talk to transportation professionals, they will say the number one problem we're trying to deal with is congestion. And the way we deal with congestion is by adding more capacity, right? If we look at flooding as a problem, I feel like we have solved this problem, right? That doesn't mean that floods don't happen. That doesn't mean that we're still not overwhelmed from time to time with water, but we actually have figured out how to deal with this problem. We used to deal with this problem by building dams, building levees, building reservoirs, doing other things. And while there were a lot of environmental issues along with that, we also discovered over time that those things actually didn't work. And they didn't work because they're difficult to maintain. We tend to not stick with them over the long term. People don't use that extra buffer capacity for buffer. They actually start to move in closer and do things that ultimately end up to be more dangerous. We've given up on this approach for multiple reasons. We don't use this approach anymore. What do we do to address water in this way? Well, what we do is we go out into the edges of the watershed and we say things like, sorry, you can't fill that wetland. Sorry, you can't run your water straight into the ditch. Oh, but it's just a little bit. It's not a big deal. Yeah, of course, it's just a little bit here, but a little bit here and a little bit there and a little bit there all add up to a big flood. And the floods are really, really difficult to deal with. The way we avoid flooding is we retain the water near its source. So how do we deal with this? The answer is not to build wider roads, to build more lanes, to build more interchanges, to add more capacity. The answer is that we have to retain those trips at its source. We have to start building neighborhoods. We have to start building corner stores. We have to start building neighborhood shops. We have to start building real neighborhoods where people can substitute an auto trip for a walking trip or a biking trip. We have to build places. And by the way, if you hung out with us at Strong Towns for any amount of time, you know that that answer is actually the other answer that we have. It's the same exact answer we have to how do we solve the financial problems that our cities are in? We have to build neighborhoods. We have to build real places. I want to end this presentation with a little thing that I do with audiences. And I do this with large audiences of people. And a big part of this is having other people hear other people give their answer. So we're going to do this remotely. We're going to do this online where you can't hear everybody else. So I'm going to interpret what I hear from everybody else, and you'll just have to use your imagination a little bit. When engineers are asked to design a street, there's a very straightforward approach that is used. The first thing that an engineer will do is say, what is the design speed of this street? They'll then look and say, what is the volume of traffic that I'm expected to handle? How many cars are going to come through here on a day-to-day basis? Taking those two factors, design speed and volume, they will go to a manual and open it up and say, what is a safe street? And then they'll sit down and figure out how much that costs. This is the design process that engineers and transportation professionals use to build streets. They start with speed, they go to volume, go to the manual and figure out what's safe and at what cost. And this process, these steps are actually one before the other. They form, in a sense, a kind of hierarchy, a series of priorities where we proceed from one to the other in that way. We start with speed, then we go to volume, then we go to safety, and then we go to cost. This is my street. This is where I live. This is 5 blocks from here. This is 4th Street North in Brainerd, Minnesota. My house is the little sidewalk on the right there leads to my house. I want you all to envision the street that you live on. Or if not the street you live on, a place where you would like to live, a place where you would like to be. And I want to ask you what your priorities are. Let's say we come and we say, we want you to design the street. You're not going to do the detailed engineering work, but we want you to lay out the priorities of what we would consider first, second, third, and fourth in designing your street. What would the first factor be? Would you be more interested in making sure vehicles could travel at a certain speed? Would you be interested in making sure we could accommodate a certain volume of vehicles? Would you be most interested in safety, that safety was the top priority? Or would you be interested in cost, making sure the investments were cost effective? Would it be speed, volume, safety, or cost? And when I ask this question, and I've done this in groups of big and small, hundreds of people, I've done this many, many, many times. I've done this in rooms of technical professionals and non-professionals. I always get the same response, right? Everybody says safety. It says safety is our top priority. It's the thing we prioritize the most. Okay, of the remaining values, would it be speed? Would it be volume? Would it be cost? What would be the next highest priority? And inevitably, people say cost. I want our investments to be cost effective. In a trade-off between speed and volume, then, would we rather have vehicles be able to travel at a certain speed, but that would sacrifice the number of cars that can get through? Or would we rather accommodate a certain volume of vehicles, albeit at a lower speed? And when presented in that way, people always choose volume over speed. This is an outcome that I've seen repeated over and over and over again. I've done this, I get in front of thousands and thousands of people, and I get the same response every time. Every time people say safety is our highest value. And that's obvious. I've done this with groups of engineers, and they say the same thing. But I want to point out here that this is safety above speed. Speed becomes the lowest value. And let me say this in a different way. We are willing to sacrifice, we as a society, we in general, engineers themselves, everybody is willing to sacrifice speed in order to increase the level of safety on our streets. Everybody is willing to have lower speeds of traffic in order to improve safety. I point out to people as we're sitting here, because it's very powerful to hear the people around you say these things at the same time as you. Because often when we show up to meetings and we're trying to narrow a street and slow down traffic and add a bike lane or do whatever we're doing, the pushback that we get is, well, no one's going to tolerate this. If you slow things down, we're going to have people here outraged, people here angry. They're going to flood City Hall. They're going to yell at the engineer. They're going to yell at the council people. Be confident. Look to your left, look to your right. Those people agree with you that the primary thing we need to focus on our streets is safety. And if that means a reduction in automobile performance, that's exactly what should happen. There's this idea of complete streets, and I like this idea. I think the inspiration behind it is really good. I will say, this is a very American concept, right? Complete streets is this idea that a street is not complete, is not a good street unless it accommodates everybody. And so the American idea is that we give a little bit of something to everybody, right? Separate but equal in a sense. If you're on a bike, you got a place. If you're on walking, you got a place. If you're in a car, you got a place. If you're on a bus, we got a place for you. Everybody gets a place. And nobody really, from an engineering standpoint, needs to compromise in a sense. I find that engineers, while resistant maybe 2 decades ago, have really come to embrace the complete streets concept. And I think it's very clear as to why. Complete streets accommodate pedestrians within an auto-dominated environment. It says we need to make sure that in this place that we're designing for vehicles, we also consider and accommodate human beings outside of a vehicle, what engineers call pedestrians. I point this out not to denigrate complete streets, because I think complete streets has gotten us to this point where we can have a more sophisticated conversation. But we need to have that more sophisticated conversation, because a strong town, a truly great place, a great street is one that accommodates automobiles, but does so within an environment dominated by people. It's people that build wealth. It's people that fall in love. It's people that start businesses. It's people that make a place great. And when we're trying to build a great street, we have to start with the people who are there and design around them as our number one priority. So let me stop here and end this presentation with just kind of where Rachel and I started it. This is our Member Drive week. Membership is a huge part of what makes the Strong Towns movement work. It's a huge part of not only the way that we fund and resource our organization and our movement, but it's the principal way that we see change happen in the world. When people become a member of Strong Towns, they become part of an overall community of people that are out shaping the conversation in our cities, our towns, our neighborhoods. They're out there meeting with other people. They're out there making change happen. And if that's not you, if you're not one of those people who are out there doing it, become a member and support those people who are. We've got dozens and dozens. I want to say it's over 100, but I know the number varies a little bit. Local conversations going on. These are people who are working in their local place to have Strong Towns ideas active in their community. We have millions of readers in our audience, lots of those who are sharing this message with their elected officials, their friends, their family, their neighbors, changing the conversation. If you want to see these ideas in your place, go to strongtowns.org. Click on become a member, sign up to be a member today. Sometimes people ask me, like, what is the minimum amount? Like, how much is it? And it's like, whatever you can do. We have some people who give us $1 a year. And I tell you what, I love those people because they've said, this matters to me. I want to be part of this. I want to do what I can. So Rachel, I said I would try to finish in an hour. Without an audience here to interact with, it does allow me to speed up a little bit.
Yeah, let's take a couple questions.
So go for it.
This question comes from Michael, who is asking about, they're considering converting a one-way street into a two-way in his town in West Virginia. What would generally be the economic impacts of this conversion? And does it create or hinder the pedestrian environment?
Wow. Well, that is let me go back to what I said about building great streets. I think great streets are really complex. And by complex, I mean they're all individual. And so it's impossible for me to say what the economic impact of that would be, if that's a good idea or not, without having like real knowledge and understanding of that place. The way that I would approach that problem is I would say, let's try it out for a while. There's an amazing amount that we can do with paint and cones and straw bales. We've all been through construction sites where they will temporarily, manipulate traffic to go in certain ways. We can go out with those same devices and try out what a new design would look like. We can run it for a month. We can run it for a summer. We can run it for a year. And we can see what the overall effect would be for people, for pedestrians, for humans, for businesses, for drivers. And we can experience that. And I would also just add to that, if oftentimes these, one-way to two-way conversions are, in most situations, those are really good things. There's some where it's maybe not universal, but most of them are really good things. But if it's not today, you may find that there's a more urgent need in the community, a more urgent place. And then 5 years from now, that might be the project that you should do. That's why I think testing these things out and giving them like a temporary run and letting see what happens is a way to kind of dynamically start to engage with streets. We tend to treat streets like something we go out and we build with a 30-year or 50-year design life in mind, as if it's not going to evolve or change over that time. And I think that's just the wrong way to think about streets.
Thanks. Relatedly, Russell's asking about, are speed bumps or roundabouts a good way to control speed?
Well, let's take those as two different things. A speed bump is basically an attempt to contradict the engineering. So let me give this to you in like financial terms. We spent way too much money building a really wide street. And so we're going to spend more money impeding the design of that street to slow people down. To me, that's like the most incoherent of responses. I've seen speed bumps work in places where there's it's looked at as temporary. We have an emergency here. We've got something we're going to do. We're going to come in and fix the street, but we're going to do speed bumps here in the short term. Long term, though, it's not a solution to anything. It's really, again, cognitive, the dissonance of it. Let's over design this for high speeds, and then let's contradict that design by putting in speed bumps. Why you would do that makes no sense. Roundabouts, on the other hand, are very interesting. Roundabouts, traffic circles, deflections in the roadway naturally do slow things down. And, I wrote in Confessions of a Recovering Engineer that I think most places that are traffic signals today could be roundabouts or even open intersections in a way that was really productive. The key part of doing a roundabout well is slowing traffic coming into it. So having the opposite of forgiving design while you're entering into the intersection. And then also having the deflections, the curves, not be the kind of highway geometries that engineers like to build with the slip lanes and the really wide curve radiuses so you can just fly right through it, but actually tightening it up so you actually have a deflection and you're entering that intersection slow. When you do that, we can accommodate a fairly high volume of traffic in a pretty safe way.
Yeah, and again, try things out with cones and temporary methods first.
Exactly.
Let's see. We have a couple questions that are basically asking, why are cities having this cognitive disconnect between designing a street that's clearly made to be driven at 40 miles an hour, and then they put the sign up or they put a slow down sign up? Why do they do this? And is there anything to be gained from putting a speed limit sign up or no?
Well, let's take those two different questions. I think the question of why do we have this cognitive dissonance is a really important one. At the end of World War II, we set out to do something astounding, something that's never been done. We set out to reshape an entire continent around a new theory of how we would build prosperity. And I know there's a lot of nuance to that. It wasn't necessarily prosperity for everybody. It was, one dimension, what have you. But I think if we are trying to be the most generous we can to people in the past, we say that their vision was, we just went through the Great Depression. We just went through World War II. We have this new, newer kind of mainstream idea of the automobile, the same way that we, those of us, I'm 49, I remember pagers, I remember early phones, I remember smartphones. If you're younger today, you just remember smartphones, like they're all around you. But I remember that transition. That's what people did with the automobile. There was the people who, it was a novelty, and then pretty soon a few people had them. Then they started to go mainstream, and then everybody had them. How can we take this invention of the automobile and use it to stay out of depression, energize our economy, give everybody a higher quality of life? And bam, we came up with this theory, this idea, really pioneered in Detroit and some other places that were a little bit further ahead, to roll this out across a whole continent. This was a great kind of, I was going to say progressive experiment, but it was a progressive experiment with a very private sector kind of approach to it. Let's do this at a grand scale. All of our understandings of these systems come from those early decades after World War II, where we figured out how to do signage, how to put in lanes, what kind of asphalt we should use, what kind of concrete we should use. And there was all this kind of like learning, a set of ideas. And we crystallized that into these programs and formats and books and codes and what have you. And that's been rolled out. It is, in a sense, a kinetic growth machine around the building of infrastructure that we created. And if you step back and look at it, it's ridiculously impressive. We can pass an infrastructure bill, and we can see now money flow to states, into state programs that push that money out to local contractors to build highways and interchanges and frontage roads. We can then watch the private sector come in behind it and build residential subdivisions and big box stores and strip malls and drive-through franchise restaurants. And if your number one preoccupation is how do we make GDP go up next quarter, we've created like a massive machine to do that. It's really hard to step back and say, if we wanted that result, GDP go up, or if we wanted like what the result should be, which is more prosperous places for people, how would we do things different? Because so much of our essence is in doing this one thing over and over. And so the dissonance is real, and it's very jarring. When you look at that traffic signal, it's painful because the dissonance is so real. But the dissonance is also very human. I don't think it's like, there are all these sites who like hate automobiles and hate engineers. And I don't think any of that is healthy, because I think what has happened is that we have just grown up with a really whacked set of expectations and understandings. And we need to confront them almost in like a gentle, thoughtful kind of way. The second part of that question then was about speed limits. And, what if we just threw up speed limits? Would that help? And like, no, unless you want a police state, unless you like traffic stops, unless you think police shootings are great, because not that I'm saying police are all horrible, but when you look at the incidents that create conflict, from a police officer's perspective, the two most dangerous things that police officers do are domestics, so responding to angry people at each other in a home, and traffic stops. A police state approach is not the right way to do this. And quite frankly, even in places where enforcement is really, really aggressive, what they find is that people still drive the speed they feel comfortable because they are human and they're using system one to drive.
All right. I know we're a little past the hour, so folks need to go. Feel free. We're going to post this recording later today on the site, but we can hang out for another few minutes and try to get a couple
I got a little bit of time. We can do a few more questions. This is kind of fun. So if you got to go, you got to go.
Yeah, we had some questions about the manual on uniform traffic control devices. Somebody asked, has it not been updated since 2009, or was that just the screenshot you shared? And then also, if people are, if there's a state or federal funding situation where they have to obey that, manual. Can we try to get it changed? Is there any efforts to do that, or is that not worth it?
Well, let's answer those. And just so you know, the MUT is what this is called internal to the biz. So the manual uniform traffic control devices, the MUT or the MUT CD, the MUT is updated regularly. So it's routinely updated in small ways. There's large rewrites that go on every now and then. I know America Walks, our partners and friends at americawalks.org worked on trying to get some of the language changed. And I think we're successful in doing that in terms of pedestrian counts. One of the offensive things about the MUT is that you get a warrant, you ask a question, should there be a traffic signal here? And one of the thresholds is have enough pedestrians died to warrant a signal. And unless enough people have died in an amount of time, you can't do it. So I think they've been successful in at least getting some of those things modified. I want to say two things about it. First, every one of these books, whether it's the Manual on Uniform Traffic Control Devices, or whether it's the AASHTO Green Book, or whatever it is that your engineers are using, they all very prominently up front say, these are guidelines. They are not laws. They're not rules. You have to use engineering judgment. And I think what we have done is we have substituted this set of industry standards for good, sound, on the ground engineering judgment. I'll go back to what I said earlier about the one-way to two-way conversion. I'm not going to stand here and say we should do that in all circumstances. I think we should do it in most, but I think we should do it with a study. And studies should not be engineers sitting down, referring to their manuals and theoretically figuring out what to do. It should be engineers going out and using temporary types of things to figure out how traffic flows in this specific location, what would be the safest way to do this, and balancing all the outcomes that we want. What is the best way to do it? In Confessions of a Recovering Engineer, I talk a lot about State Street in Springfield and how it was poorly designed, poorly reconstructed, and how that has led to the death of not just Destiny Gonzalez, but a whole slew of other people. There was another death there this last November, and the city after that went out and did exactly what we've been calling for them to do. They went out with cones, they went out with barrels, they went out with paint, and they temporarily redesigned the street to see if they could get better outcomes. They did get better outcomes. And now, right now, today, they're in the process of making those better outcomes permanent. We can substitute that process and approach on our local streets for design manuals that are built around highways, not around our local conditions. And we can do that using the manual because it says, use your engineering judgment. If you do a design that doesn't fit the AASHTO Green Book or the MUT CD, and you can document the reasons why you're doing that, here's the study we did, here's the tests we did, here's the assumptions we did, here's the outcomes we have. You are not going to have you are going to have more liability protection than following the stupid manual mindlessly and watching people die.
Amen.
Amen.
Let's take at least one last question here, because this one comes up a lot. This is from Kate. How do you explain these street design issues to fire marshals and others that are trained to prioritize designing for catastrophe over day-to-day usage?
I'm looking for Jeff's specs book back here. Oh yeah, here we go. I think Jeff, Walkable City Rules. Jeff, I love you. He does the best. He's got the best explanation of that, best answer for that I've seen. And that is engage your fire marshal and your police officers as public safety officials, not as a fire marshal or a police officer. When we treat these people like their job is to respond to fires, that's your job. You respond to fires, you respond to crashes. Your job is response. The way that they improve response is to improve response time. What are the things that make it more difficult for me to drive to this crash? Now, talking about automobile crashes, a lot of the things that make it easy for a police officer or a firefighter to respond to a crash are the same things that cause the crash, right? wide lanes, over-engineered, all this stuff. But if the only thing we're asking them to do is to respond quickly, they will become very protective and very defensive of their designs. And they will insist on overly wide lanes, overly wide recovery areas, overly wide things. If we instead ask them to be our partners in building safe systems, I think then the engagement can start to change. And yes, some fire officials need to lose their jobs and go away. Some police chiefs need to lose their jobs and go away. But the vast majority of them are really concerned with overall safety. And if we can make them part of that safety conversation, I think they can become really strong advocates for good street design. Incidentally, we are about to launch, and we rolled this out for our members last week. I don't think I don't know how public we've been about this, but we will soon be launching a crash analysis studio. And the idea of this crash analysis studio is to demonstrate an approach to analyzing, learning from, and adapting from the crashes that happen in our own communities. And so we're going to hold a studio, a workshop, over multiple months to look at different crashes and demonstrate a way that you can, in your community, start to analyze your own crashes and actually build a local body of knowledge from that, one that would ultimately supersede the Green Book and the MUT CD and all these other things that are hampering us from doing good design. As part of that process, we want to invite public safety officials to be at the table because, we think that they have really good insights and we think that they can be part of the solution. Not to say that there aren't some that need to go away, some that need to retire, some that need to move on, some that have an antiquated view, but that's true of engineers too. There's a lot of them that have antiquated old views, but there's a whole ton of them that want to see stuff be different. Cool, Rachel?
Yeah. All right.
All right.
I think this is probably a good place to wrap it up. I'm going to put a link in the chat right now. If you didn't get your question answered, we have a whole Q&A platform on our Action Lab, which is, there's also a ton of resources and articles related to a bunch of the stuff that we've been talking about today, how-to guides, success stories, and all that. So definitely head over there if you'd like. And otherwise, thank you so much to everyone who came. Thank you to our members that make this possible. And thanks, Chuck, for a great presentation here.
Hey, thank you, Rachel, for all you do. And yes, a special thank you to all of our members and everyone who's made this possible. I remember doing member drives 6-7 years ago, and it just felt overwhelming then. The number of people that would show up and the number of people who would donate and the number of people who cared passionately. And I kept promising them, we're building a movement. The support that you are giving this organization is so that you don't feel alone, so that at some point in the future, there's going to be thousands of you. There's going to be millions of people talking about this. This will become the way we talk about cities. And it's astounding to see how much that has actually happened. We've got a long ways to go yet, but boy, this is a very exciting time to be part of this conversation. So thank you, everybody, for being here. And thank you particularly for all you members. Keep doing what you can to build a strong town. Take care, Rachel. Take care, everybody.
Take care, everyone.